Hey folks, Bryan Costanich here. I am co-founder and CEO of Wilderness Labs, and I am here to talk to you about modernizing SCADA in critical infrastructure. And really what we're going to talk about is how IoT is upending legacy SCADA systems by making them more responsive, resilient, and reliable. Now, if you're watching this, you probably already know that IoT is revolutionizing the world. But what you might not know is that it's making its biggest impact in the industrial sector, where roughly 60% of the IoT market lives. And the promise of embedded computing has given us the ability to put compute in nearly everything, everywhere, right? And now there are nearly 2 IoT devices in the world for every human. And of course, those are not evenly distributed around the world. And so in developed countries, those are really more like 6 to 10 devices for every human. And that's going to double in just a couple of years. And nowhere is IoT disrupting things more than probably in industrial SCADA today. And that's because secure IoT is a real game changer, right? So the ability to put microcompute in industrial context that is like low energy, low cost, low complexity devices, they can be attached in situ in industrial context on industrial machinery, or in scenarios where traditional SCADA equipment is really untenable. And to sort of drive the point home here, compare a $10,000 SCADA remote terminal unit to a $100 IoT device, and you can kind of see what's happening here. But before we get into that, I think the first thing we have to ask is, what the heck is SCADA, right? Well, SCADA is an architecture, and it stands for supervisory control and data acquisition. And this is an architecture that is really about controlling industrial orchestrations, right? And it's not a specific set of technologies. It's really a monolithic pattern for connecting programmable logic controllers, remote terminal units that are things like sensors and sensor interfaces, and then HMIs or human machine interfaces. And then, of course, the communications and infrastructure that ties all these things together, right? And it's important to know that basically everything in industry is built on SCADA. Nearly every industrial process control system is run by SCADA, and city infrastructure, critical infrastructure, all these things that we think of as being in those sort of places, such as municipal water supplies, sewer systems, traffic systems, bridges, bridges that open and close, etc. Also power generation, whether it's hydro, wind, solar, geothermal, etc. All of this stuff is really run by SCADA systems. And if this architecture is sounding familiar, it should be, right? Because this is very similar to modern IoT, right? In modern IoT, we have like sensors, we have human machine interfaces, we have supervisory control, that is some backend and dashboards, and these things are communicating together. And really, this is about orchestration of data at the edge to the cloud or some other backend, and then also those, the cloud or other backends being able to control those devices at the edge, or those devices doing smart things, right? And then the main difference between IoT and SCADA is one of a decentralized architecture versus a centralized architecture, in the sense that like SCADA is usually run by some computer that's probably a desktop tower sitting under someone's desk at a power company or something, whereas IoT, by its very nature, is sort of loosely coupled and sort of tied together in a sort of decentralized way, right? And one of the things about IoT is that IoT architectures have a ton of advantages over these legacy SCADA architectures. For one, they're far more flexible. SCADA systems are fossilized to the original build and are incredibly difficult and expensive to change. Whereas IoT solutions can be upgraded and extended pretty easily. And IoT devices can operate in places where SCADA often can't reach, right? So with IoT devices, you can put remote installs where they're running off of battery or solar and communicating over long distances via like LoRaWAN, for instance. And many things that are easy in IoT are functionally impossible in SCADA. And a lot of this is because SCADA is really based on technology from the last century, right? And because of this, from a modernity perspective, SCADA systems are also just very old, and they are incompatible with like modern workflows like CI/CD, AI, machine learning, DevOps, etc. Whereas IoT is really at home in those places because that's where it grew up, right? That's where it was developed, and SCADA systems rely on like clunky legacy programming technologies like ladder logic, and IoT systems are built on like standard protocols, languages, support a wide array of communication channels and UX frameworks, etc. And so IoT is programmable and extensible by regular software developers, where with SCADA, you need a specialized controls engineer to come out and make changes. And of course, if you need to do that, then pull out your checkbook, your pocketbook, and wait a month or two to get someone scheduled, right? And from an observability standpoint, there's also a big distinction here because SCADA systems are built around the idea of instantaneous state. So when you're looking at a SCADA HMI, it's typically you're seeing the state of the system right now. There's no histrionics. There's no history of what the state is. You can't roll back and like look at what it was, a week ago or whatever. Whereas IoT systems can not only take advantage of time series data and message flows, but are oftentimes just built on those types of things, right? So that gives you the ability to not only predict what's happening in the future based on historical data, but you can actually see over time whether or not a machine is going to go down, and you can tack on things like a vibration sensor, right? And you can see that data over time, and you can run AI and ML workloads, and you can do some really interesting things there that you can't do with just an instantaneous, snapshot of a system. And of course, SCADA carries significant risk around a lot of these things, a major one being obsolescence, right? Because as legacy SCADA parts fail, there may not even be replacements for those devices. They may not even be available anymore, right? And security is an interesting place where SCADA carries risk because much of these legacy SCADA systems were built before security was really even a concern because they were never meant to be hooked up to the internet. Heck, the internet didn't even exist when a lot of these SCADA systems were built. And so much of it is completely open, and it prevents it from being remotely integrated, right? It prevents SCADA systems and orchestrations to be managed remotely or incorporated into a larger orchestration context. And this is super important in the context of critical infrastructure and city infrastructure, right? Because oftentimes you might have different systems that in order to be resilient and flexible need to talk to each other, and there needs to be some remote management saying, hey, we need to do something over here in this system because something's happening here in this system. And that's really impossible in SCADA. And of course, maintenance is a real challenge in SCADA systems because it requires organizations to buy expensive on-site service agreements with these companies, and there's often a long lead time to get folks out to look at these things. And what's happening here today is really interesting because there's a major disruption that's going on in SCADA systems, and the reason why is because of there's a number of factors here, but the first one is that the SCADA industry has become very anti-competitive. It's been dominated by three major providers for decades, and anytime that a smaller player has emerged, they've actually been purchased, they've been acquired by these bigger companies. And what's happened, and when we're hearing this from our customers, is that now they're getting fewer features and poorer service, but they're being charged more money. And the tech itself, like I said, is locked to the last century. And also, I mentioned this as well, is that from an accessibility standpoint, with IoT, software developers can program hardware, right? But with SCADA, you need to get these specialized control engineers to actually do this. And so it's really undergoing a radical shift right now in the industry. And while that's true, it's important to point out that actually SCADA and IoT solutions can coexist. And we're seeing this a lot today. So one of the things is that IoT can provide a path forward for upgrading and extending legacy SCADA systems, and IoT devices can plug into SCADA systems by serving in the various SCADA roles, right? So SCADA has like 5 major roles. There's remote terminal units, there's gateways, there's HMIs, there's the supervisory computer itself, and then there's the infrastructure that the communications happen, and those roles are easily serviced. Many of those roles are easily serviced by secure IoT devices. So you can actually take a legacy SCADA system and you can start to put IoT devices inside that system, and they can operate within that context. And so in this way, IoT offers an incremental path forward for migration and modernization of SCADA systems. And like for one example of this is like, okay, so one of the roles of a SCADA system is a gateway. So exposing a SCADA system to the external world. You can do that with secure IoT. You can actually connect a device there to the internet, and then that can receive commands remotely, and that can talk to the SCADA system without exposing the entire SCADA system. And we've seen customers actually doing really interesting things with IoT and SCADA. So for instance, the municipal water treatment facility the next county over has been using IoT to get better information into their SCADA systems in both previously unreachable locations. So water treatment, natural water treatment, way out in the field, or even upstream data in creeks and things like that, as well as like back home at the plant, right? We're seeing them drop in IoT to read existing SCADA sensors and whatnot, and then upload that data to the cloud. And then that data can be looked at from a time series perspective, and then also pushed into their SCADA backend for the instantaneous perspective. And we're also seeing, the Navy is doing maintenance operations where they can get a better view of systems while performing maintenance, right? So you can imagine that someone goes out to look at a boiler, and they can have live information from sensors on these critical infrastructure, and as well as like being able to pull up technical manuals and information about maintenance that needs to be performed. And it makes this, much more efficient and much safer. We also seen folks doing energy monitoring and vibration monitoring on industrial equipment to see things like, oh, well, this machine is drawing too much amperage, and so maybe the motor needs to be replaced, or there's a particular vibration, and maybe there's a bearing that needs to be replaced, or in a CNC, an automated CNC, like there's a particular vibration that indicates chatter, and so it needs to slow that mill down, right? And so that's a really interesting place in which we're using modern IoT technology in SCADA systems, in industrial systems, right? And so a lot of this is possible because of the support that we've built into our Meadow platform, right? Meadow is really built for industrial IoT, and we've got a pile of built-in support for industrial protocols and industrial voltage comms, etc. So for instance, MODBUS RTU, MODBUS TCP are fully supported, both MODBUS server, MODBUS client. We support and have built-in protocol support for MeterBus or MBus. The Project Lab board actually has RS 485 voltages built right into the screw terminals here, so you can actually plug in RS-485 Modbus sensors, and then as well on the Project Lab board, you can actually add click boards in the microbus slots for 4 to 20 milliamp analog industrial sensors, right? So what this is allowing us to do and allowing our customers to do is bridge the gap between legacy systems and modern backends, right? From low-cost sensors, IoT sensors, you can plug those into SCADA backends, and you can do just the opposite too, right? So imagine getting data from like a remote terminal unit, intercepting it with a secure piece of IoT, running AI or machine learning on that, and then changing the settings or what's happening in a programmable logic controller in response to the machine learning outcome, right? So these are really interesting things that you can do now in SCADA systems with secure IoT. And I've actually invited Adrian Stevens along to give us a demo of some of this stuff in action. So let me bring up Adrian here and we'll see how you can use an industrial sensor in Meadow.
Thank you for the introduction, Brian. So here I've got a sample industrial sensor. This is the Yosmatech Y4000 multi-parameter water quality sonde. So this device is, of course, used to measure water quality and be used in things like streams, rivers, actuaries, and oceans. And this is used by, municipalities and commercial entities to, measure water quality. And I want to show you how we hook this up to a Project Lab V3. Of course, we have this set up here on my desk, running off a benchtop power supply. And just take a look at the sensor. This is not a small device. This is not a common off-the-shelf device. This is a commercial level sensor. It's almost 18 inches or 45 centimeters tall with all the cabling. And we have this hooked up through the RS-485 screw terminals on the bottom of the Project Lab. You can see that wiring here. And I want to show you how we use this in a Meadow application. So I'm going to switch over to Visual Studio. I've got a project built here already. And the first thing we would do if we're going to add Y4000 support to a project, we'd pull in the NuGet package. And so we would do that here. We can right click and manage NuGet packages. This is kind of fun. So if I browse for NuGet packages in Visual Studio, you can search for Y4000. Check this out. It's actually the only package is the one available from Wilderness Labs Meadow for the Y4000. And we would bring that in. This is going to give us access to all the capabilities of the device. And I want to just go through a couple of things in the code pretty quickly. So we are using Project Lab. There's another NuGet package for Project Lab to make a lot of these things easier to consume. And so here in our project, we instantiate the Project Lab, and there's a factory method here called create, and this gives us a Project Lab object. And this is important because we're going to use this to talk to the Y4000. Use a controller pattern. It's a common pattern for industrial applications and the way it orients our code. So we've got a water quality controller, and here we call initialize method. We're going to right click, go into here. And the reason I want to show this to you because I want to show you how we create the object to represent the Y4000. So we have a field. And then notice here on line 18, so Project Lab get MODBUS RTU client. So we can get a MODBUS client straight from our Project Lab object and set the baud rate 9600 for our device. And that gives us a client object, one line of code, and then one more line of code to instantiate our Y4000. Now, and then you see here, we've got some updates. We can monitor when sensor updates. We initialize sensor, and this is really powerful. So if I go in to do this initialize method, this is pretty neat. This is where all the plumbing happens. And so inside initialize, you see here, we're starting the Modbus client, and this is connecting, of course, this is to connect to the device. But I'm actually within the Y4000 driver. So let me just show you one example of how we actually do the communication here. So let's just do something straightforward, like getting the serial number. So get serial number. So notice right here. So this is a public method. We can call this, but look what it's doing here. So we've got an async pattern, and we're going to read the holding registers, right? We're using Modbus, and these are all defined within the driver. So if I go into the registers, you can see there's the register defined for the serial number. And if I go in here and go to this definition, and there's registers for all the things we can pull from the device, and of course include the data. And there's a lot going on in here. We're wrapping up the Modbus library. We've got all the definitions for the Y4000. And the beautiful thing here is, as an IoT developer, If you're building a solution with the Y4000, you don't have to write any of this code. This is all included in the NuGet package. It's all open source. It's all there, and it just works off the shelf. Now, of course, if you're building a new driver for another sensor that isn't yet supported, well, then you could dive in and do this work. But it's great for things already in Meadow Foundation. You don't have to do any of that work. Let's go back to the app. I want to just jump over, won't go through too much, but again, you can see it's minimal code to get us up and running. And I just want to show you a little bit of how we get the data back from the device. So when we run our application, we call start updating. This is a very common pattern you'll see in drivers in Meadow Foundation. I give a time span 1 second, so I'm going to add data every second. That's really nice for a demo here. Might do a little bit longer in an actual application. And just our display controller, I want to show you consuming this because you get a sense of the power of this driver. So we call update display. We're actually giving it the full data package, all the values from the Y4000. And look what we're getting back. Dissolved oxygen, the chlorophyll concentration, the blue-green algae, the electrical conductivity, pH, temperature, a ton of stuff. But not only do we get these values, but we get these values with units. So look at the consumption here for temperature. I don't just display the temperature, but I say, hey, I like the temperature in Celsius. I can change this to Fahrenheit. I can change this to Kelvin. Everything has the appropriate unit. So we're ready to go. We're not worried about what the value means. We know what we've got. And again, we can just jump in. And again, not a whole lot of code to display this. And if we go back, we can see on our display, it's exactly what we're doing. We're displaying our temperature in Celsius, our pH, our dissolved oxygen as well. Now, of course, we can get some other values, but a lot of these values don't have a lot of meaning while we're not in the water. But again, I really want to show you just how quick and easy it is to include these industrial level sensors in a Meadow application using Project Lab. Thank you again, Bryan.
Hey, all right. Thanks, Adrian, for that. Yeah, very cool to see, that how easy it is to take an industrial sensor like that and just plug it in and then have an API for it, very plug and play. And you can imagine with this kind of functionality and with plugging this secure IoT stuff into legacy SCADA systems, you can imagine what cities and critical infrastructure could do, right? So think about like smart traffic systems that could adjust traffic flow to accommodate events like parades or something, or streamline stretches of traffic signals to optimize rush hour throughput, right? I could imagine commuting across Los Angeles, for instance, and if some of those long streets had synchronized signals, you could just really increase the flow of traffic and reduce a lot of the bottlenecks in the side streets. Or during emergencies, you could reroute traffic completely. Or like what we're seeing with our customer, with their water treatment system, they can now manage in real time wastewater holding based on upstream, literally creeks and rivers, the flow there to prevent accidental discharge out into water systems. Or they can catch polluters discharging chemicals with IoT devices in sewers. And they can much more efficiently manage waste fermentation and prevent bacterial die-offs through AI and ML, and watching, how the biome is changing over time and what's coming in, and making that much more efficient. Or, a city could optimize trash pickup, right? So they could see current trash capacities and problem areas in real time and learn from that histrionic data to optimize routes based on predictive, based on prediction, based on how those things have been happening in the past. And so, in conclusion, I think that IoT is really a game changer for SCADA systems. Cities and critical infrastructure can take advantage of these solutions and augment or extend these fossilized legacy SCADA installations and do it, and move faster and cheaper and add really interesting, functionality and features, things that you can't really easily do in SCADA system. And these solutions can provide a path forward for completely new experiences from an infrastructure, a citywide, countrywide, level. And we have made that sort of an integration super, super easy with industrial peripheral support and all of the protocols that you need to use, etc. And so, yeah, I'm really excited about what's happening in this space. And I think that there's a lot of opportunity to really make cities more reliable and resilient and do it through secure IoT. So thank you for joining me, and I hope that you enjoy the rest of this amazing Hackster Impact Summit, and I will see you around. Thanks, folks.